All right, friends, it's your boy, Mr. Shaney, coming at you with Unit 3, Lesson 3, Making Scaled Copies homework. And so our first question to say says, here are 3 polygons. You have a triangle, you have sort of a slanted quadrilateral, and then you have what appears to be a parallelogram, or it looks like a parallelogram. Doesn't look like a rhombus. So it says, draw a scaled copy of the polygon using a scale factor of 2. And so notice that there are no side lengths given here. So basically what they want you to do is they want you to learn how to use an index card to basically measure your side lengths, right? So I'm gonna measure the side lengths as accurate as I possibly can. So that's about that side length there. So what I'm gonna do for this is I'm going to double that. So I'm gonna take that one time. Right, and this is not necessarily gonna fit on your paper a little bit because I didn't plan for that. So I apologize in advance. So that's 1, and then I'm gonna double that. So I'm just gonna do it again, match it up as perfectly as I can. So that's the base of that triangle. Then what I'm gonna do is I'm gonna go back and I'm gonna measure the height of this. So the height of this is that long, and we're gonna double the height. So the height is a little longer, so do that. And then we're gonna do that again, so that's the height. So you can kind of see that this is overlapping a little bit. And then what we're gonna do to find the slanted one is we're gonna take our index card and we're gonna connect those 2 lines there, because if we've done it perfectly, this should be scaled appropriately by 2. And so that is triangle A, scaled by a scale factor of 2. And so that's how we do that part. This part is gonna be a little messy. So we're gonna scale this by half. So we're gonna take half of the measurement. So if I'm gonna measure here, I'm gonna think about approximately half. And so what I'm gonna try to do is do about halfway there. That's gonna be, about half of that using that index card. I'm gonna bring this down. So this should be about the base. I'm gonna try to keep it at the same sort of angle that it's at. So this is the bottom of that. Then I'm gonna measure the side like this. I'm gonna look for a halfway point here. Halfway point between there. It's a little further in. So remember that this is, not necessarily exact, but it's something, so I wanna keep it how it is. So I'm gonna line that up, bring that card down just like that, and go to this line here. So that's about halfway there. And then we're going to do the opposite side. So I'm gonna remove the card like this. Halfway looks like it's here again. So I'm gonna bring that down like this. Kind of like tilted. So keep that sort of line like that so that you get your thing. And I want to put this on it like that so that we get the line that I'm looking for. And then I'm just gonna connect like this. So this looks a little off, and you could tell this is like a little human error on my part, but the idea is that you understand how to find half of it given an index card. And so this is about as close as I can get to be, so I just wanted to be scaled by half. And then this here, C is gonna be a little different. So C, you're gonna scale it by 3.5. 3.5 is you're gonna take a whole length of it, right? So a whole length would be here. And then you're gonna take half of that length. So this one's gonna be a little harder. So if this is my whole length, right? If that's a whole, then I wanna take half of that, right? So half of that would probably be, if that's my line, half of that would be somewhere like that. So then I'm gonna extend it out a little further. And remember, this is me, using some approximation and some, trying to understand what I'm doing here. I wanna try to get another side so that I'm not getting confused by all my markers that I've identified. So this is my whole, right? The whole side length is about here. And we're gonna do like that. I wanna match this up as best I can so that the angle transfers as well, because remember, scaled copies have the same angles. So if I'm not careful, I'm gonna not make a scaled copy. This is drawing, right? So there's a hole, right? It's not perfect. So then we're gonna do half of this line. So half of it is about right there. So take it up there, extend it. And then we're gonna do it across. Across should be about the same as the bottom. So the bottom itself, right? So we're gonna measure that. That's my hole. Right, so it's almost perfect there. I think I'm gonna use this side again because there's my hole and there's about half of that hole. So I think here would be, I'm gonna do that. I'm gonna do that. And then I'm gonna try to put this at the angle that it is so that you get the same sort of angle here between those two lines. Right, so that's about as close as I'm gonna make it for those three things. So really what you're doing here, so this, I know some of you are gonna think this is an exact science, so I'm gonna give all of you an index card and I want you to basically use the concept of, could you scale something by 2 or by half or by 3 halves if you're given an index card as your way to do it, right? And so really the skill here is we're focusing on using this index card to rebuild something either by a scale of 2 or by 3. So that's the skill that we're just practicing. It doesn't have to be perfect, but it should be pretty close, right? So question 2 says quadrilateral A has side lengths 6, 9, 9, and 12. Quadrilateral B is a scaled copy of quadrilateral A with its shortest side of 2. So this shortest side is 6, and then it's going to go down to 2. So what's happening here, right, to make 2? Well, some people are going to see that that's an automatic division of 3, right? So I divided by 3 there. So if I divided by 3 there, another way when we're talking about scaling is dividing by 3 is the same thing as talking about multiplying by a third. A third is the reciprocal of 3, right? So I could divide each one of these by 3 because it asked me what the perimeter is. Remember, the perimeter means the distance around an object. So I'm going to take these numbers and I'm going to add them up. So I have 2 plus 3 plus 3 plus 4. Well, I know that this is 6. 6 plus 4 is 10. 10 plus 2 is 12. So my final answer for that problem is 12, and it's 12 units. Okay, so that's that part here. Here's a polygon on a grid, so you can't really tell that there is a grid here. So that seems to be a problem on when I'm making this copy. I think it ran out of ink, so you could almost tell there's some grid here. So I'm gonna have to tell you all exactly what these measurements are. So this is 1, right? So that measures 1 cube. You can kind of see that. That's 1, 2, 3. This is 3. This is 2. This is 1. This side is 1, and this is 2. So it says draw a scale copy of this polygon that has a perimeter of 30 units. What is the scale factor? And explain how you know. Well, so perimeter I know is 30, right, of my new figure. What's the current perimeter? So 3 plus 1 is 4, plus 2 is 6, 7, 8, 9, 10. So this currently has a perimeter of 10. So 10 times what number equals 30? Well, that will be times 10 times 3. So my scale factor is 3, and I know that because 10 times 3 equals 30. So that's how I know. So I'm going to draw this the best I can because you don't really have the grid there. So you're going to have to get real close. So I apologize to people because I can barely see the lines, and I know that you're probably going to have that same issue. So I can see some lines starting here. So maybe that's 1, 2, 3, 4, 5, 6, 7, 8, 9. So this side is 9. You want to indicate that you've scaled that by 3. Multiply this by 3. So that's 1, 2, 3. Then you're gonna go scale this by 3. 1, 2, 3, 4, 5, 6. Right, so that might be 6. And then you're gonna scale that by 3, that's 3. 1, 2, 3. And then you're gonna go down another 3. 1, 2, 3. And then you're gonna come across. So this is 9, 3, 6, 3, 3, 6. So in that, if I add all that up, it should give me 30. So 9 plus 3 is 12, plus 6 is 18, plus 3 is 21, plus 3 is 24, plus 6 is 30. So perimeter, right, is scaled by the same number. That's what we're dealing with today. So perimeter is scaled by the same as the sides. Okay. The last problem says Covey and Isabella are discussing the figures shown below. Covey thinks that B, C, and D are scaled copies of A. Isabella says B and D are scaled copies of A. Do you agree with Covey or do you agree with Isabella? First, I want to talk about the side links here. So this one came out a little better. So this is 1, this side is 1, 1, 1, 1, 1. So I'm just going to compare two sides. This side is 1 and this side is 2. So this side was multiplied by 2, but this side was not. So B is not a scaled copy of A. So I'm going to get rid of that. This side is scaled by 2, but this side is scaled by 1. So looking at 1 and scaling that by 2, that does not work either. So C does not work. It's not a scaled copy. This one is scaled by 2. This side is scaled by 2. So this one looks like it is properly scaled. So this one, D, is a scaled copy. So D is the only one that's scaled copy. So now this is my scaled copy. Now I'm going to answer the question. It says Isabella, so Covey thinks B, C, and D, and Isabella says B and D. Neither of them are correct. I'm sorry if I haven't zoomed out here. Neither of them are correct because D is the only scaled copy. Because D is multiplied by 2 on each side, the other ones do not apply a scale for each number. So that's our homework for tomorrow. I can't wait to see you.